So at this point, we know all about elasticity and why some goods are more elastic than others. But now we want to know what implications elasticity has for the shape of the demand curve. In general, if our demand curve is flatter demand implies a bigger elasticity, price elasticity to be specific, and steeper demand corresponds to a smaller price elasticity. And we can see this graphically or build some intuition graphically. So with a flatter demand curve, right, that means we have a smaller slope, which means our demand curve is going to look something like this. What that means is when we have a change in price from P1 to P2, the change in quantity demanded is going to be quite big compared to the price change. So we have a relatively small price change and a relatively big change in quantity demanded. On the other hand, when we have steeper demand, that means we have a large slope or a large rise over run. And so our demand curve is going to look something like this. And if we take a similarly sized change in price as before, we get a very, very small change in quantity demanded, as you can see here. So again, larger elasticities correspond to flatter demand curves, and smaller elasticities correspond to steeper demand curves. We can get more specific than this though, right? We have a scale where we have the most inelastic demand here, and we go all the way to the most elastic demand. And we have 5 categories. One is what we call perfectly inelastic demand. Then we have inelastic demand. Right in the middle, we have what we call unit elastic demand. Then elastic demand. And finally, perfectly elastic demand. So first we have perfectly inelastic demand. And recall our notation for price elasticity of demand in our formula, which is percent change in quantity demanded over percent change in price. And I'm introducing some new notation here, which is Greek delta or a triangle, which just means change, so percent change. And we say demand is perfectly inelastic if it has a price elasticity of demand of 0. And so the only way this expression here can be 0 is if a percentage change in price corresponds to no change in demand, which means we'd get a 0 in the numerator. So graphically, this is going to correspond to a perfectly vertical demand curve. And so to see the intuition, we can pick a price, let's say P1. Let's follow that over to the demand curve. And then we follow it down to the x-axis to get our quantity demanded. So Q1. And now let's say price decreases to P2 and repeat. And we get the exact same quantity demanded. So some percentage change in price corresponded to a 0% change in quantity demanded. And so consumers that have perfectly inelastic demand, we say they have no price sensitivity since they don't change quantity demanded regardless of how big the change in price is. So our next classification is inelastic demand. And we say demand is inelastic if the price elasticity of demand is less than 1. And the only way this expression is less than 1 is if the numerator is less than the denominator, which implies that the percentage change in quantity is less than the percentage change in price. And so graphically, inelastic demand is going to be relatively steep, maybe something like this. And let's pick a price, P1, find the corresponding quantity demanded, and then let's change price to P2. And you can see there's very little change in quantity demanded. And if we were going to describe consumers with inelastic demand, we would say they have relatively low price sensitivity. Next, we have unit elastic demand, and we say demand is unit elastic if the price elasticity of demand is exactly equal to 1, which again, referring to our formula, the only way this is 1 is if the percentage change in quantity exactly equals the percentage change in price. And graphically, it's going to be a demand curve that's less shallow than what we had before. And so if you pick two prices, the percentage change in price, let's say this is a 10% decrease, then we should see a 10% change in quantity demanded. And if we had to describe consumers with unit elastic demand, we would say they have intermediate price sensitivity. Next, we have elastic demand, and that's going to be defined as a price elasticity of demand of greater than 1. And again, we can refer to our formula to learn something about this. If this is greater than 1, then that means the numerator has to be bigger than the denominator. And so the percentage change in quantity is going to be larger than the percentage change in price. Graphically, this is going to be a shallow demand curve, or one with a small slope. And so picking our prices, we'll see that a small change in price will lead to quite a large change in demand. And consumers with elastic demand have a relatively high price sensitivity. And finally, we have perfectly elastic demand, and that's going to be defined as a price elasticity of demand that is equal to infinity. So this is not intuitive and kind of confusing. But again, let's look at our formula and think about what that means. So if you've had calculus, you know, if this expression is going to infinity, one reason that might be is that the denominator is approaching 0. So the limit of the price elasticity of demand as the percentage change in price approaches 0 equals infinity. But basically what it's saying is we're going to have a 0 in the denominator and some value in the numerator. So a perfectly elastic demand curve is going to be one that's completely horizontal. And so what perfectly elastic demand is saying is that at a 0% change in price, as in price doesn't change at all, you could still have a change in demand because all these values on the x-axis are consistent with that price. The other implication of this is that if price changes at all from this value that corresponds to the demand curve, so we could go up to P3 or down to P4, well, then demand goes to 0, right? Because if we draw a line across, right, our rule for finding quantity demanded is we take the price go over till it hits the demand curve, then down to the x-axis. But if we go across here, it never hits the demand curve. And same thing if we decreased price to some value other than P1 or P2. And so consumers that have perfectly elastic demand um, have extreme price sensitivity. Or in other words, any change in price implies quantity demanded goes to zero. So I have one final point here, which is that if you have a linear demand curve, you might think that since the slope is constant and slope corresponds to the elasticity of demand, or maybe more specifically, slope governs the elasticity of demand, that a constant slope means a constant elasticity. But that is not the case, because as you move down the demand curve, the magnitude of your change might be the same, but the percentage change is different, right? That means the percentage change going from 30 to 20 is not the same percentage change as going from 20 to 10, even though they're both changes of 10. And so I'll leave it as an exercise for you to verify this. But the elasticity across this change from 20 to 30 is 5. And then from 20 to 10 is 1. And from 10 to 0 is 0.2. And so we have elastic, unit elastic, and inelastic demand all on the same demand curve, linear demand curve. So again, I'll write this for emphasis. Constant slope does not imply constant elasticity.